Hey, what is up mga bis? So example number 7 na tayo sa pag-solve ng deflection in beams using the double integration method. Let's go. Alright. Ayan, so kung makikita nyo mga bis, no, yung example natin is a simply supported beam. Pero yung loading niya is unsymmetrical. Meron tayong triangular tsaka point load. So, let us try to take a look kung ano yung required. Sabi dito, let us determine the maximum deflection of this beam. Okay, so tulad ng mga previous examples, let's start with the formula. So, yung EI natin, ito, given na yan, di ba? So, no need to worry with that. Let us worry with M, or our moment equation. So, this moment equation, makukuha natin yan after we do a cut section, di ba? So, dito mga bis, di ba yung pinagpuputulan natin is dito sa pinaka-rightmost, just before our support. Pero kung makikita nyo mga bis, no, kapag puputulin natin to, yung loading natin magiging trapezoidal siya. So, kailangan, kapag isusulatan yung moment equation, kailangan nating hatiin siya into a rectangular, tsaka triangular, magiging dalawa. So, medyo mas mahirap yun, kaya I choose na i-flip ko na lang to, no? It will still not be a problem. Parehas din naman yung sagot na makukuha natin, okay? In that case, kapag finlip ko siya, no, kapag puputulin na natin dito, yung loading natin na to will stay as triangular. So, no need to expand the moment equation, no? It will be simpler. Pero yung mga magnitude na yan, same pa rin yan. Okay? So, ito, 20 to 15. Huwag niyong balik na rin yun, 20 pa rin to, tsaka 15 to. Okay? So, before we do a cut section, let us determine the reaction here at B. Yung reaction at A, no need na yan kasi puputulin rin natin dito and di yan may include yung nasa left side lang. Okay? So, let's go. Simulan na natin. Ito, RB. Let's say that's RB and we will use summation moments with respect to A para B yung masolve natin. Okay, so let's solve for that. So, summation of moments with respect to B. Ay, joke lang. A pala. Ay, paiba-iba ako na sinasabi. A is equal to 0. So, clockwise moments natin, positive. Counterclockwise, negative. So, simulan natin. Meron tayo ditong RB, yan, positive kasi clockwise moment yung magagawa niya. Then, the moment arm is 3 plus 1.5 plus 1.5 is 6 meters. Next, meron tayo ditong triangular load. Okay, so yung triangular load natin, pag i-convert natin yan into a point load, it will be located here, di ba? At yung converted point load niyan would be the area of this triangular load. So, that is 15 times 3 divided by 2. So, that's 15 times 3 is 45. Tama? 45 divided by 2 is equal to 22.5. So, yung converted point load yan would be 22.5 kilonewton. Alright, now, yung ating point load na to, it is located 2/3 mula dito sa 0 point, di ba? So, sa length na to, 2/3 from here. Ibig sabihin, yung length na to would be equal to 1 kasi yung natitirang 2 ay 2, di ba? Kasi 2/3 ng 3. So, this is 1 meter. Okay? So, with that given, pwede nating masulat yung moment nito. So, that would be equal to a negative moment kasi it will create counterclockwise moment. Negative 22.5 times the moment arm, 1 plus 3 is 4. Okay? And then, sunod natin yung 20 kilonewton na point load. Same then, it will create counterclockwise. So, negative yan. And yung moment arm niya is 1.5. So, equal to 0. Ayan. So, pwede na nating masolve yung RB. Okay. So, ito. So, RB. Okay. So, pwede natin masolve yung RB. So, RB is equal to 22.5 is times 4 is 45 times 2 would be 90. 90 tapos ito plus. Parang nilipat na natin sa kabila, no? So, ito 20 times 1.5 is 20, 30, di ba? 30 divided by 6. So, this is 120 divided by 6. Therefore, 20. Kasi 20 times 6, 120. Tama. So, yung RB natin, mga bis, has a value of 20. Ayan. Now, since we are able to find out the value of reaction B, then proceed na tayo sa pag-solve ng ating moment equation. Okay? So, i-erase ko lang to since di na natin to kailangan. Alright, so ngayon, puputulin na natin to, di ba? Yan, so nang pinutol natin yan, drawing our free body diagram. Ayan. So, meron tayo ditong reaction na 20 kilonewton. Tapos, meron tayo ditong triangular load. Ayan. Ang triangular load natin, ang magnitude nito is 15 kilonewton per meter. Then, meron tayo ditong point load, which has a magnitude of 20. Okay? So, ilagay ko lang yung mga distances nila. Ito, that is, ilan to? 3 meters. Tapos ito, this is 1.5. And this whole length, mula dito kung saan natin pinutol hanggang sa left end is the length x. Okay? So, ngayon, we need to write our moment equation. Clockwise moments positive, counterclockwise negative. Yung reference point natin is yung cut section kung saan natin pinutol. Parang ito yung magiging pivot point, no? So, simulan natin dito sa 20. Itong 20 kilonewton force will create a clockwise moment positive. Therefore, that would be 20 times the moment arm, which is x. Clockwise, so positive. And then, punta na tayo dito sa ating, ito munang mga point loads, no? Para hindi mag-iba-iba. So, itong 20 na point load na pababa, it will create counterclockwise. So, negative 20. Ano yung moment arm niya, mga bis? Ang moment arm niya would be this total length x minus ito, di ba? Kasi ito yung hinahanap natin eh. It would be x minus this length, which is x minus 4.5. Ayun. So, okay na tayo dito. Next, punta na dito tayo sa triangular load. Ang triangular load natin will create a counterclockwise moment, di ba? Iikot siyang pag ganun. So, katulad ng ginawa natin dito, convert muna natin to into its converted point load. So, same. Magkakaroon tayo ng 22.5. Ayan. 22.5 kilonewton. And yung distance niya, say this distance is 1 lang, di ba? So, sulat na natin to. Ito mga bis, ang magnitude niya, converted point load would be negative 22.5. Then, we multiply it with its moment arm. Yung moment arm niya would be equal to this total length minus yung natitira dito, which is 2, di ba? Kasi this whole length is 3, this is 1, this is 2, to make it 3, okay? So, ang this moment arm natin, this distance, yan, would be equal to this total length x minus 2, so that is x minus 2. Kaya ito, x minus 2. Okay, so, ayun no, this, that's it mga bis. This will be our moment equation. So, ito yung pa-plug natin sa ating formula to solve for the maximum deflection. So, plug in ko lang dito. This will be EI. Y prime would be equal to M. That is 20x minus 20 times x minus 4.5 minus 22.5 times x minus 2. Okay. So, let's now integrate. First integration in terms of x. So, first integration, may magkakaroon tayo ng EI, Y prime. So, double prime pala ito. Nung integrate natin, naging Y prime. So, ito magiging 20x squared over 2 minus 20x minus 4.5 naka-square ay plus 1 sa exponent, so magiging squared divided by 2 minus 22.5 times x minus 2 naka-square to. I-square natin yan taas over 2. And don't forget yung arbitrary constant C1. So, simplify natin para mawala itong mga fractions. EI y prime is equal to 10 x squared minus 10 times x minus 4.5 squared minus, ano ba yan? Hindi na. Sige, 22.5 divided by 2 is 11.25. Tama ba? Yes, I think so. X minus 2 squared plus C1. Ayan. So, for the second time, kasi nga, double integration, di ba? So, integrate ulit natin to. So, this is our slope equation, no? Ngayon, magiging deflection equation na. Y prime magiging Y. Ito, that is still 10x. X at 2 plus 1 is 3. Yan. Minus 10. X minus 4.5. 2 plus 1 is 3. Over 3 minus 11.25. X minus 2. 2 plus 1 is 3. Over 3 plus C1 magiging C1x and another arbitrary constant kasi second integration na tayo. Okay, so we're done with the integration portion. Before we can proceed to solve the maximum deflection, we need to determine first our arbitrary constants, C1 and C2. And how are we going to do that? We use boundary conditions like ano ba yung mga alam na natin na values ng deflection dito sa ating beam initially without solving anything first. And we know that at supports, deflections there are 0. Thus, we can say that at x is equal to 0 or here at this portion, your y or deflection is 0. Same likewise dito. When your x is 6, di ba? 3, 1 point, tama. X is equal to 6, our y is equal to 0. So, we can use these conditions to solve for C1 and C2. So, let's start with first this, 0, 0. Para ma-eliminate natin lahat, then we can solve for C2. So, at x is equal to 0, your y is also equal to 0. So, plug in natin to sa deflection equation and we can solve for C2. Okay, so kung mapapansin nyo mga bis, no? We plug in y equal to 0. 0 times ei will be simply 0. Is equal to ito. X is 0. So, 0 times 10 will simply be 0. Minus. Ito mga bis, that will be 0 minus 4.5. That has a value negative 4.5, right? Pero, we are following the Macaulay principle na when x minus a is less than 0, we cancel that term out. And since 0 minus 4.5 is negative 4.5, that's less than 0, we cancel that out so we don't include it. Okay? So, ayan. Kaya parang 0 na rin lang. Ayan, minus 0. Next, itong term na to. Lagay natin yung x value which is 0. 0 minus 2 is still negative 2. Negative number pa rin. So, cancel that out. It will not be included. So, parang 0 rin lang. Plus ito. 0 times C1 is still 0. Okay? Plus C2. Therefore, we can conclude that the value of our C2 is 0. Okay? Continuing with that, let us solve for the value of C1. Gamitin na natin tong x equal to 6 and y is equal to 0. So, when your x is equal to 6, your deflection or y is equal to 0. So, we plug in this sa ating deflection equation and solve for C1. Okay, so eiy, y is 0. So, 0 times ei will still be 0 is equal to, ito, may value ng x natin. That is 10 times 6 cube over 3 minus 10. Ang value ng x natin is 6. So, makapapansin nyo ito, di ba? 6 minus 4.5 is positive 1.5. Since it's positive, i-include natin siya, okay? Unlike dito, na negative, kaya hindi nga natin siya in-include. So, 6 minus 4.5 is 1.5. Cube over 3 minus 11.25. 6 minus 2 is 4. Cube over 3 plus C1 x. C1 ito yung unknown, di ba? Yung x natin is 6. Plus C2. Yung C2 natin is 0. So, no need to include. Therefore, we can solve for C1, di ba? So, calculator na lang natin yan. We will have... So, the value of C1 is negative 78.125. Okay, now, alam na natin yung values ng ating arbitrary constants, C1 and C2. Plug in natin dyan, so kompleto na yung ating deflection equation. So, what's next? Going back to the problem, ang tinatanong niya is the maximum deflection. Diba kapag alam natin yung location ng maximum deflection, pwede natin itong masolve. Usually, yung mga examples natin sa mga example 1, 2, and 3, I think, and for mga simply supported beam, na symmetrical sila. Kaya, certain tayo that the maximum deflection occurs at the midpoint, sa midspan mismo. However, sabi ko, diba, kapag unsymmetrical, if you remember, no, kapag unsymmetrical, it is not at the midspan. However, it is very near the midspan. So, for this case, no, napansin ko na very negligible pala yung effect and sometimes it goes wrong. So, I think it would be best na lang to assume that the maximum deflection occurs at the midspan. That is when it is a simply supported beam, no? Kahit unsymmetrical na yung it is very near the midspan. So, let's just assume that the maximum deflection would occur at the center. Okay, kung bakit, I will explain it to you mamaya. But for now, let us solve the maximum deflection. So, let us set x equal to 3 and dito, solve natin yung value ng ating y. Okay, so, ayan. Ito, y at x is equal to 3. Let us solve for our maximum deflection, which is y. Okay, now, ito, gamitin natin yung deflection equation na to. Y is equal to 10x. Ang x natin is 3 nga, diba? So, 3 cube over 3 minus 10. Ito mga bis, hindi ko na to i-include. Bakit? That's 3 minus 4.5, which is a negative number. So, according to Macaulay's method, cancel that out. No need. Punta na tayo dito. 11.25 times x minus 2, that is 3 minus 2, which is 1. 1 cube over 3 plus C1x. Ang C1 natin is negative 78.125 times 3 plus C2. What's the value of our C2, mga bis? That is 0, di ba? Okay, so 0 yan. So, no need to include pala. Okay, then we need to divide here our EI. Kasi yun yung formula natin, di ba? Nakababa yung EI niya or the flexural rigidity. EI, and what is our EI? We have here 200 gigapascal, 200 GPa, and meron tayo ditong 65 times 10 raised to 6. 65 times 10 raised to 6 millimeter raised to 4. Now, katulad ng ginawa natin sa ating mga previous videos, kailangan parehas yung units sa numerator at denominator. Dito sa numerator, yung mga ginamit nating units dito is in terms of kilonewton at meter. Diba? Yung moment equation kasi is doon nang galing sa numerator, nang galing yan dito. Kilonewton siya, tsaka nakameter yung distances. Same likewise sa baba. So, convert natin. And we know that 1 gigapascal is equal to 1 million, or let's just say 10 raised to 6 kilonewton over meter squared. Yan. So, that is 1 GPa. So, we can cancel GPa and GPa. Now, our units in force is naka-kilonewton tsaka naka-meter. So, next, convert naman natin itong mm raised to 4. So, 1 meter is 1,000 millimeter, right? And we need to raise that to 4. So, cancel mm, meter na lahat. So, no problem with that. Okay, so yung makukuha nating value dito, mga bis, would be equal to negative 0.01139 and so on. So, that would be in terms of meter. Kasi, meter yung ginamit nating values dito. Or in millimeter, that would be 11.39 mm. So, this is negative because pababa siya. Okay? We expect that the deflection would go down kasi yung loading naman natin is pinupush siya downwards. Kapag nag-positive yan, dapat pataas rin yung deflection mo. So, it's kind of way of checking your answer. Now, let us go back to the question of the location of maximum deflection. So, usually, di ba, yung alam ko kasi, at the point of the maximum deflection, your slope is 0. Therefore, pwede natin gamitin itong slope equation. We set our y prime or this slope equal to 0, and then we solve for the variable x kasi alam naman natin yung C1a. Okay, so with that, masosolve dapat natin yung value ng x, which would give us the location of the maximum deflection, di ba? So, nung ginawa ko yun, mga bisno, you can try it on your own. I set this y prime equal to 0, di ba? So, C1 natin is negative 78.125. So, nag-shift solve ako. Of course, since quadratic equation yan, we would have two values. And of course, we will only consider yung values na nakuha ko dyan is equal to x equal to 3.34 tsaka 8.65. Of course, disregard na natin ng 8.65. That's not the root that we are looking for. Because 6 meters lang naman yung span natin. So, it doesn't hindi siya applicable doon. So, itong 3.34, yan yung hinahanap natin. Okay, so in my theory, when our x is 3.34, supposedly yung ating slope or y prime should be 0. That means the location of the maximum deflection is at 3.34. Dito, konti, no? Since this is 3 meters, nandito siya konti. So, since alam natin that the maximum deflection will occur at 3.34, ipa-plug in natin to ngayon dito sa ating equation. Itong mga 3 na to, papalitan natin ng 3.34. Ito magiging 1.34, of course. So, nang ginawa ko yan, that is 3.34, I got an answer of y. I got an answer of y which is equal to negative 0.01121 meters, or in millimeters, that is 11.21 millimeters. Okay, so makita nyo mga bis, no? They are almost the same, no? That point something, ano ba to? 0.20 something or 0.18 something is negligible enough, naka-millimeter pa. Pero yung point ko is, hindi ba dapat mas malaki yung itong 11.21? Kasi nga, the maximum deflection is dapat nandito sa 3.34. Yung midspan natin is 11.39. So, I think, no, for these cases, no, for simply supported beams, it is very safe to assume that your maximum deflection will still occur at the midspan, regardless if your loading is symmetrical or not. Diba? You see the difference? I'm not sure if may mali ako sa solution ko, or I don't know if I missed something out, no? Okay, so kindly comment down kung sakaling alam nyo kung ano yung kasagutan dito sa pag-aalinlangan sa ating utak. Okay, so it would greatly help mga bisno. But for now, at least we are certain of one thing, that is that our maximum deflection will occur at the midspan. Almost, if not. Okay? Very near. Okay? So, ayun mga bisno. And if naman, ayun, and if, because, kasi it will still give you a very same answer kumbaga eh. And I'm not sure lang if okay lang ba na error yung point something na mangyayari. If ever na, tama pala yung ito. Yung ito, di ba? Pero it doesn't make sense eh. Dapat mas malaki to, di ba? Kasi nga maximum deflection, bakit mas malaki yung midspan? Ayun lang. Naguguluhan din ako. Pero ayun mga bis. So, yung answer kasi natin dito na nakita ko sa reference book is naka 11 mm lang. Hindi siya naka 11 point something. Kaya di ko sure kung sino yung tama. Okay, so ayun, that's it mga bis, no? If you have some questions, sana nakatulong to sa inyo, no? Or kung mas naguluhan man kayo, sorry na po. Okay, so ayan, maraming salamat sa panonood. If you have some questions or clarifications, wag mahihiyang magtanong sa amin ng generic. Kaya nga, di ba? So ayan, that's it mga bis. Please like, share, and subscribe. Muli ako ba yung mabuyong na nagpapalala sa inyo kung maglakbay mag-enjoy maglaro ng leksik. Maging matinik. Jabi out.